Okay, folks, I wanted to give you guys a little help with review. So I thought I would do a couple of these problems. You could try a couple of your own and see how it goes, okay? Y varies directly with x in problem 3. Write and graph each direct variation function. So if y varies directly with x, we've got y equals kx. When y is 2, x is 6. So k is going to equal 1/3. So then our function is y equals 1/3 x. And if you wanted to graph that, that'd be a line up 1/3. And there we go. Alright, so that's number 3 there. Alright. So then they give us y varies inversely with x for number 7. And they asked us to graph it. So y equals k over x. Because as x gets bigger, y should get smaller. And they tell us that y is 3 when x is 2. So then k equals 6. So our function is actually 6 over x. And if we're graphing that, it should look something like this. As x is 1, y is 6. As x is 2, let's see, 1, 2, 3, 4, 5, 6, y is 3. And as x is 3, y is 2. And it's going to come down. Oops. Let me erase here. It's going to come down, hit our points, and swoop on. Alright? Asymptote right there. So that's our inverse property. And then they ask, determine whether the data set represents direct or inverse variation or neither. Well, direct variation has to have a constant. So does inverse. And as x gets larger, y needs to get larger for it to be direct, or in this case, y is getting smaller. So then we just need to see, is there a constant between them? So they need to be constant. So if if they're inverse, right, we have y equals k over x. So then k equals xy. If it was direct, it'd be y equals kx. So k would equal y divided by x. So we test those two things to see if there's a constant. In our case, xy is 50 for the first one. Right here, 25 times 2 is 50, 10 times 5 is 50, and 5 times 10 is 50. So that's pretty constant. It's definitely not direct because as x gets bigger, y is getting smaller. That's the opposite. So it looks to me like it's an inverse variation. Alright? Alright, so you might try a couple other of these. Alright, and then come in with questions if you have them. Alright, so here we're either simplifying, multiplying, or dividing. So I'll do one from each section for you. Alright, so let's do the most difficult one over here. So number 13, you got to factor the top and bottom. So you get x plus 4 times x minus 3 over x plus 1, x plus 4. Alright, now, just as a reference for the future, at this point, I already know that x would never be allowed to equal negative 4 or negative 1. Because if it did, this denominator over here and this one here becomes 0, which we're never allowed to divide by 0. So, but these cancel. So my simplified version is x minus 3 over x plus 1. Alright? Now, that makes negative 4 a whole and negative 1 a vertical asymptote. So if I wanted to find the y value of my whole, I would need to plug in and say -4 minus 3 over -4 plus 1, which equals -7 over -3, or just 7/3. Okay, so -4 comma 7/3 is my whole, whereas this -1 is a vertical asymptote. All right, but we're not graphing here, just finding values for x that are not allowed to happen. So -4 and -1, and this is my simplified rational expression. All right, to multiply, let us do, I'll do 16 here. 16. 16 is x squared plus 2x minus 3. But you know what? I'm going to factor that. I'm going to factor everything out. Make my life a little easier. So I get x plus 3, x minus 2, or excuse me, minus 1, over x minus 2, x plus 1, alright, times x minus 2 over x plus 3. So, right off, I know that x can't be -3, 2, or -1, because in both of these denominators, they become 0 if x is ever -3, 2, or -1. So we need to cancel here, and we cancel here, leaving just x minus 1, x plus 1 on top of each other. And that would be my simplified expression. Okay? For division here, I'll do 19. 19 is a good one. So if I factor the first numerator, I get x plus 5, x minus 3, all over x minus 2, times, now I'm going to flop these two because we're dividing by a fraction, which means you flip and multiply. So I get 2 times x minus 2 over x plus 3, x minus 3. Alright? Cancel, 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 cancel. Nothing else cancels. But I also know that x can never equal to -3 or +3 because of where our denominators are. Alright? And then we simplify and say it's just x plus 5 over x plus 3. So again, we'd have a vertical asymptote here and whole here and here. And these, if you're trying to find the y values, you'd plug into our simplified guy. So we'd have holes at, looks like 3 plus 5 over 6, which is 8/6, or 4/3. That's one whole. 3 4/3. 2 plus 5 is 7, 2 plus 3 is 5, so we'd have 3 4/3 as a whole, and 2 7/5 as a whole. Okay? Alright, here we are adding rational expressions, so we have to create common denominators. Alright? I'm going to try to find one here that has a different a different denominator. So let's do 25. Or no, better yet, let's do 24. X over x plus 2, x minus 2, plus 1 over x minus 2. This again is number 24. Okay, and I just factored the first denominator. So this first denominator is missing an x, or excuse me, is missing nothing. But the second denominator is missing x plus 2. So I'd have to multiply by x plus 2. But if I'm doing that to the bottom, I got to do it to the top. So we do it x plus 2 over x plus 2. So then this whole problem becomes x over x squared minus 4 plus 1 times x plus 2. Sorry, 1 times x plus 2 over x squared minus 4. x squared minus 4. So, let's see. We end up with 2x plus 2 over x squared minus 4. Nothing cancels, so that's all we got. Alright. Again, that's from doing x plus 2 on top, all over x squared minus 4. Alright. Hope that helped. Let's see. The LCM. LCM is like the number that would eliminate those denominators, right? LCM, least common multiple. So let's look at 26 real quick. We've got x squared minus 9, which is x plus 3, x minus 3. Again, our goal is always to factor LCMs. So then we get x minus 3, x minus 3. And so in order to create an LCM, you take each of the factors to their highest power. We have x minus 3 squared, and then we have x plus 3 to the 1. So times x plus 3, that would be our LCM. Okay, and you could distribute that through if you wanted to, but you don't have to. All right. Again, if these two numbers were denominators and you multiplied their problem by this LCM, both denominators would cancel, and in the numerator you would end up with different things left behind. Okay? Alright, I'm going to erase some stuff here. So take a minute, make sure you have all this down. And there we go. Alright, so number 20, no, let's go number 30. Alright, so I'm going to write it in factored form, 1 over x minus 3, x plus 2, minus x over x plus 2. Alright, again, this is missing an x minus 3. The other one is not missing anything. If it had been missing something, you would multiply it by what it's missing. So x minus 3 over x minus 3. So we get 1 over x minus 3 times x plus 2 minus x squared minus 3x over x plus 2 x minus 3. Okay? So when you subtract, you get negative x squared plus 3x plus 1 all over our LCD of x plus 2 x plus 2 x minus 3. Okay? There's no factors of negative 1 that add up to 3, so this numerator is not factorable, so there's our final answer. Okay? So that was number 30. Alright. 33 is a good one. X plus 3 over 3x times 6x minus 9 over x squared minus 9. If you look at this, okay, this problem here is a fraction over a fraction, and so all I'm doing is flipping and multiplying. Alright? So then I need to factor everything. X plus 3 times 3x, or excuse me, over 3x times 3 times x minus 3 over x plus 3 x minus 3. X minus 3's cancel, x plus 3's cancel, and the 3's cancel, leaving basically just a 1 over x. That's my answer. Okay. Alrighty. Okay, graphing rational functions. The most fun we've had all year. Alright, so let's look at these examples real quick. They tell me that g of x is 1 over x minus 3. Alright, 1 over x minus 3. So since the numerator is lower powered than the denominator, we know that y equals 0 is our horizontal asymptote. But then we have this k value translating us down 3 units. So the horizontal asymptote becomes y equals negative 3. Alright, and then our graph goes like this, and they would pick x values that are to the left, or excuse me, to the right, and to the left of our vertical asymptote, which is at x equals 0, because the denominator of that function is 0, or is x. Alright? Same thing here. We have 2x minus 4 over x plus 3. So the top has the same power as the bottom. So that means that y equals 2 over 1 is going to be my horizontal asymptote. Then we look at the denominator, it's x plus 3. So that means that x equals negative 3 is my vertical asymptote. I would pick x values like, I don't know, 1, negative 1, 0, and then get some points that ride along here. And just know that your graph is going to ride along the vertical asymptote, hit those points, and then ride along the horizontal. Same thing here. I'd pick some x values that are to the left, like negative 4, negative 5, negative 6. To the left of my vertical asymptote. Find those points and plot them, and then just ride along the asymptote, hit those points, and go. Okay? So let's graph one real quick. We've got 41 here. 41 looks good. We get x minus 3. We write it in factored form. X minus 3 over x plus 1, x plus 5. So nothing cancels, so there's no holes. Okay? Nothing cancels, so there's no hole. And that means that we're going to have vertical asymptotes at x equals negative 1 and x equals negative 5. The top power is less than the bottom power, so we're going to have a horizontal asymptote at y equals 0. Automatic. Alright? And then if I graph this, do that here. First I go to negative 1. Actually, we'll do 3, 4, 5. So negative 1 gets my asymptote. Negative 5 gets an asymptote. X equals negative 1. X equals negative 5. Okay? And then my horizontal asymptote, I'm going to put in red just because it's sitting on the x-axis. Y equals 0. Alright? And then let's put in blue all of our points. So again, I'm going to pick like different x values, solve for their y's, and plot them. So I'm going to start with, say, 0, because it's over here to the right of this vertical asymptote, over here. I'm trying to determine, does my graph ride like this? Does it come up and hit here? What happens? That's what I'm trying to figure out. So wherever the points lie, okay, that's where I know this thing's going to kind of go. And it doesn't have to be perfect, it just has to go through the 2 or 3 points you create, ride near an asymptote, and go. Occasionally you might see ones do this, where it goes up, comes over, and then back towards the asymptote. But not often, and probably not on our test, okay? So, back to the raft here. If I plug in 0 to my original function, I'm going to end up with negative 3/5 as my y value, okay? And so at 0, we're at negative 3/5 over here, alright? Maybe I'll plug in x equals 1. So I get another good image. So 1 minus 3 over 1 squared plus 6 plus 5. So that's 12. So it looks like negative 2/12 or negative 1/6. So at 1, we're even closer to the asymptote. So it looks to me like it's going to come here, hit those 2 points, and then shoot on down. So that gives me that section. Then I need in between, so I'm going to pick like negative 4, say. Let's do negative 4. Alright, and I'll erase this work so I have some room to work here. In fact, so we get negative 4 minus 3 over, we'll go negative 4 plus 1 times negative 4 plus 5. So that's negative 7 over negative 3 times 1. So that's going to be 7/3. Alright, 7/3 is a little more than 2. So that means at negative 4, we're at 1, 2, and a little more like that. Alright? Now, I need to probably get, I'm going to go closer to my other asymptote so I can kind of see how it reacts. and I'm going to get, let's pick, -2. So -2 minus 3 over -2 plus 1 times -2 plus 5. So that's -5 over -1 times 3. So that's going to be 5/3. Alright, so 5/3. So at 1 we're at 5/3, which is going to be a little less than 2. Alright. And then let's see what happens at -3. Alright. -3. Make sure I erase. Let's give myself some room here. -3. So we get -3 minus 3 over -3 plus 1 times -3 plus 5. So that gives me -6 over -2 times 2, which is -4. So that's going to be 3/2. So it looks like at -3 we are at -3 or positive 3/2, so we're at 1.5. So I'm thinking this is going to come down through our points and shoot back up. Alright. And then we need something to the left of our other vertical asymptote, our x equals -5 vertical asymptote. Well, -6 is an x value to the left of -5. So -6 minus 3 over -6 plus 1 times -6 plus 5. So that is -9 over -5 times -1. So that's going to be -9/5. So -9/5 is a little less than -2. So we're going to be at -6. We're going to be at -2 just about. Alright. And then we'll do the same thing for -7. -7 minus 3 over -7 plus 1, -7 plus 5, -10 over -6 times -2. So that's positive 12. So that's going to be -10/12 or -5/6. So -5/6 is going to be a little less than -1. And so our graph is going to come, hit those 2 points, and just shoot on down. Alright, so there's our graph. Alright, so the next sections will be in the next video because I need to do these in chunks. Alright, hope that helps.